Okay, so I think we can start. So hi everyone, thanks for coming. It's another episode of NLP with Friends. And today we're very excited to have Mo Geva. So Mo is a PhD student from Tel Aviv University. She's also an intern at A to Israel, and she's advised by Jonathan Durant. Yeah, and today she will talk about Aristotle. So Mo, go ahead.
Sure. I'll share my screen again. Okay. Yeah. Hi, everyone, and thanks for joining. And also a big thanks to Yanai and NLP with Friends organizers for holding this great seminar. Today I'll be talking about a recent project that we've been working on for the last year and a half with great people from Tel Aviv University, A2, and UPenn. And this is about a new type of question answering benchmark with implicit reasoning strategies. Feel free to ask questions during the talk. I'll try to stop once in a while. And yeah, we also have time at the end for questions and discussion. Okay, so let's dive right in. A lot of attention has been given to developing models that can reason over multiple parts of their input. Many data sets have been released recently, like Hotpot QA and Drop, where a model is given with some context or should retrieve a context and then answer questions while reasoning over multiple parts of this context. But in most multi-hop QA data sets, well, the questions are such that the steps for answering them are actually mentioned or hinted in the question itself. And what do I mean by that? Well, let's take, for example, this question from Drop. What event happened first, Jabal Shammar being annexed or the preliminary attack on Taif? Well, to answer this question, right, you should have 3 steps. You should check when each of these events happened and then just compare the results. But you can see, well, that it's clear from the question how, I mean, the steps are clear from the question, right? You should be able to answer this question even if you don't know who's Jabal Shammar or what it was the attack on Taif, right? Let's see another example. How old was William Duval when black gives way to blue was certified gold by the RIAA? This question is from Hotpot QA. Personally, I don't know who is William Duval, and I'm not familiar with the RIAA, but still, I mean, if I would give you access to I don't know, your favorite web search engine, Google, Bing, I don't know, you could easily find the answer, right? You would know exactly how to get the answer to this question. And this is because the steps are mentioned in the question, right? You should know that, okay, first I should just search when this certification happened, and then check how old was William at that time. So, and this is like the common case if you look at current multi-hop data sets. Well, but in real life questions, many times the steps for answering the question are implicit. They're not obvious from the question. Take, for example, this question. Did Aristotle use a laptop? How would you decompose it? How would you answer this question? It's not obvious from the question itself, right? I mean, if you would use the fact that, I mean, most people would know, right, that Aristotle lived many years ago, and the laptop is a recent technology. And therefore, the steps here would actually quite similar to those of the previous example, right? We should compare, oh, sorry if there's a background noise, by the way. We should compare the times when Aristotle lived and when the laptop was invented, and this would give us the answer, right? The reasoning steps here, though, are implicit in the question, in contrast to the examples before. And to answer such implicit questions, well, the reasoning steps should be inferred using a strategy. The strategy is the approach for answering a question. I'm going to show you 3 more examples now, and I just want you to pay notice to the fact that the steps for answering each question are not obvious from the question itself. You should use some implicit knowledge to decompose these questions. So here's the first one. Would a monocle be appropriate for a cyclope? Should a finished website have lorem ipsum paragraphs? And this one is actually my favorite. Can one spot helium? Let's take the last one, for example. To spot helium, well, if I would ask you to answer this question using Google, let's say you don't know the answer, you would probably use your knowledge that, well, in order to spot something, in order to spot helium, you should be able to sense it with at least one of your human senses. So the reasoning process here is quite complex, while the question is very natural and simple. It's just called implicit knowledge, requires implicit knowledge. Let's take questions at this point. I hope, I mean, this is important. So if there are any questions, I'm happy to answer. Can you still hear me?
Yeah.
Yep, all good.
Okay, great. I can see nothing but my screen, so, okay.
Yeah, so if you have a question, you can raise your hand on Zoom and we'll take it from there.
Okay. So answering implicit questions is challenging compared to their explicit variants in 2 ways. Well, let's take as example these two, the previous example about Aristotle and some explicit variant of it, right? So the implicit question is, did Aristotle use a laptop? And the explicit one is, was Aristotle alive when the laptop was invented? And so imagine for a second the context for answering these questions. So for Aristotle, it would be probably some paragraph, like background paragraph about who Aristotle was. And for the laptop, it will be some, I don't know, paragraph about the history of laptops, saying that the first laptop was invented at some point. So given that, well, considering the implicit version, well, there's little overlap between the question and the context for answering it. This makes context retrieval hard. And the second challenge is, well, you could also see it like with this example that questions that require implicit reasoning, well, they often tend to be short because they do not express all the reasoning process to answer them. So this reduces the chance for reasoning shortcuts, like it has been shown in Hotpot QA, for example. So the goal of our project was to collect a data set of such questions. But at the beginning, well, we noticed that many types of questions falling under this category of implicit reasoning. So we had to refine our definition a bit. And for that, we defined 3 more properties, like desired properties strategy questions should have. So the first one is implicit reasoning, as I said before. We also want questions that require reasoning over more than like a single local text in the context. We want reasoning over multiple parts of the context. So we want multi-step questions. Another important property is we want questions with a definitive answer, or at least very likely. Well, we've noticed that there's a big class of questions that fulfill the first two properties of implicit and multi-step. And these are opinionated questions like, does chocolate taste better than vanilla, for example? I mean, you could argue for and against each of the possible answers, and the reasoning will be implicit and multi-step. But the question, I mean, there's not just one correct answer to this question. So in this project, we wanted to focus on questions with definitive answer. And the last property is that we want questions that can be answered from some context. So we had to choose a corpus because this depends on the corpus. And we chose Wikipedia because it's open domain and pretty informative. So these were like the four properties that define strategy questions. And maybe you've already noticed this, but we also chose to limit ourselves to yes/no questions for two reasons. The first one is that it lets us focus on the complexity of the questions rather than the output. And also it limits, it prevents statistical cues between the question and the answer. In contrast to, for example, span extraction, question answering, etc., etc. So this was our goal. And the big question of this project is, well, is it possible to collect such questions? This is like not obvious at all. And I'll try to explain why. But first, let's see if there are any questions at that point. Okay, I'm moving on. So yeah, I mean, okay, the common practice for collecting QA datasets is through crowdsourcing. And usually it works like this. You choose some context and show it to crowd workers, and then you just ask them to write question about this context. Now, this introduced multiple problems, but first, the workers write questions while seeing the answer in the context. This creates shortcuts and biases, but maybe even I don't know, maybe even more important, it limits creativity. I mean, the worker is given with the entire information, I don't know, to write the question. And for strategy questions, well, we need some implicit knowledge. And to think about this implicit part, well, you need creativity. And if we would just provide the workers with all the information they need, it's bad. It really limits creativity. So this is like the first challenge. The second challenge, I don't know, I think it's even more challenging. This is basically the way workers are doing their job. I mean, I don't know how many of you have experience with crowdsourcing, but what usually happens is that a worker, I mean, he or she tries your task, and then as they go, they adapt patterns of all kinds, like language patterns, writing style, even, I don't know, specific methods to complete your task. So let me give you an example. Let's say I would publish, I don't know, strategy question writing task. And then there will be this worker who really likes the Aristotle example from before. And it requires temporal reasoning. And I don't know, this worker really likes it. And then he just used the same pattern again and again and again. And he or she writes many good questions. I mean, they're implicit, they're multi-step, they have a definitive answer, and you could probably answer them from Wikipedia. But still, I mean, it's the same strategy again and again and again. So this behavior of crowd workers, it really limits diversity. We don't want a data set of just temporal reasoning. We want to explore what kind of strategies people use when answering questions. So these are like major challenges. And I don't know what we can do. What can we do? So in this work, well, we employed two main methods. The first one is, well, we basically just turned the crowdsourcing pipeline upside down. Instead of starting with the context, well, we start from the question. Instead of showing the workers an entire context, we prime them with terms. And what are these terms? Well, these are just concepts, 1, 2, 3 words, not more than that, sampled from Wikipedia. We use popular terms that most people will be familiar with or can easily relate to. So we can see one example here, cell. But you can say, you know, there are many types of cell. So what do you mean? So we also attach a short description for context. This short, I mean, this context is like, it's less than 1 sentence. It's just like a very short description just to provide context, not more than that. And well, we ask workers to write strategy questions based on this term. And well, because this is all they're given, they have to use their background knowledge and web search skills and imagination, creativity. And this creates, this is like this inspires the creativity and also diversity, because every worker brings a different background knowledge. So this is the first method. Are there any questions at this point?
Yeah, how do you get these terms? Like, where do you get them from, or how do you sample them?
So these terms are Wikipedia titles, page titles. And we had to do some filtering, of course, because there are, you know, many pages are like, I don't know, about uncommon terms. So we filtered by the number of incoming links to the page and the number of contributors. So this gave us like a good portion of terms that sounds pretty common.
I see also Daniel has a question.
Yeah, can you hear me?
Yes.
So even if you enable creativity, most workers will find shortcuts to not be creative and spend less time, right? How did you reward creativity? Or is it the next slide maybe?
This is the next slide. This is a great question. Oh, I see like there's a message, 2 participants raised hand. Anyone wants to ask, just feel free to ask.
Excuse me. Yes, Mo. Well, maybe you're going to relate to it later, but I haven't heard Daniel's question, so I don't know. The short description contains, I suppose, several facts about the term. So any fact that is not in the description is considered negative? Is it?
Yeah. If I understand what you're saying, you say, well, the description contains some information, so maybe the workers will just ask about this information provided in the description, right? Is that what you're asking?
For example, about Aristotle. So he was born here or there and did this and that, but there is nothing said in this. But first of all, maybe he did other things that are not, maybe he liked to drink orange juice, but it is not written in the description, but it is written somewhere else. So if you ask, if the worker asks, did Aristo like to drink orange juice, he would think the answer is negative, but really, it's not a good example. Think of something more substantial. But really, the answer will be no, but in reality, the answer is yes. And second, the in such a way, I don't know what about your title, because do you expect the annotators to come with questions such as in the title about Aristo using a laptop, which I think he did, by the way, but never mind.
Yeah, so you had two questions. I'll start with the second one. The second one, you asked if we expect workers to come up with questions like in the title. So the answer is yes. I mean, like in the title, I assume you mean questions fulfilling the properties I described before. And for the first question, well, we don't ask the workers to write questions about the description. We ask them to write questions about the given term, like ask question about sales, ask question about Aristo. The description is just provided so they will know what is this thing they should ask question about. To come up with a question, they should use their knowledge or do some web searching. That's the idea.
I see. So you don't rely on the short description as the only source of information.
No, not at all, not at all. No, this is just, yeah. Mm-hmm. Okay, any other questions? Okay. Oh, yes.
Yeah. So were you concerned at all about how natural the questions were? So I don't think someone would actually want to know if Aristotle used a laptop, because I think it's obvious. Were you at all concerned about natural questions when building the data set?
I think I understand your question. Are you saying that the questions are not like interesting? They're sort of common sense? Is that what you're asking?
No, it's more that they're manufactured and not in the wild, right? Sorry to interrupt.
Representing like someone's information seeking need.
Sorry, can you repeat that?
Yeah, so I mean that they probably don't actually represent some information that somebody actually wanted to know, because people would already know this.
Mm-hmm.
So was that something you were concerned about when building the data set, that the questions are somewhat natural and not manufactured or artificial in some way?
Oh, I actually don't think the questions are artificial. I mean, usually people don't ask like obvious questions. I will share some examples later, so maybe this will help to answer your question.
Thank you.
Okay, I'll move on just because to keep up with the time. Okay, so yeah, this method is to inspire creativity. But there was this second issue, if you remember, that we have this limitation on diversity. And to solve this, well, we implement modeling the loop filtering, and I'll explain exactly what this means. So let's say we have a candidate question written by some worker. We pass it through two groups of solvers. First one is a group of pre-trained models, like Roberta Large, pre-trained on multiple data sets. I can provide the details later. It's not that important.
Well, I think more froze. Yeah, it's not just for me. I guess we will reconnect in a moment.
Can someone call him?
Hi, sorry. I just disconnected, I think.
Hi, let me make you, you're still the co-host, so I think you can still show.
Yeah, hello, can you hear me?
Yeah.
Okay, I'm so sorry. Let's continue. Yeah, my Wi-Fi connection is not great, but I hope it will be okay now. Okay, yeah, so when exactly did it froze?
You said that you had multiple models pre-trained on some, or fine-tuned on QA data, and that's it.
Great. So yeah, so we passed the question. We ran this question against these solvers, and if at least 4 of them answer it correctly, then we assume the question is too easy and we reject it. Now this part is not about diversity yet, but I had to mention this because it's part of the solution. But now comes the diversity, increasing diversity part. We passed the question through another group of 3 different solvers. These solvers, we are fine-tuning them during the data collection. They're fine-tuned on questions written previously to this candidate question. So if there were repeating patterns or the same strategies were used again and again, we expect these models to capture them and be able to answer a new question that is very similar to the previously written question. So if at least, if all the 3 solvers answer the question correctly, then we assume it's biased or very similar to previous question and we reject it. And otherwise, we accept this question. So this mechanism is to increase diversity and avoid like patterns used by workers again and again.
So is this done during the time they write questions or afterwards?
So every batch of examples, like after every 500, 1,000 question, we just fine-tune the solvers on all the questions we have so far.
Okay. Thanks.
Okay, I'm moving on. So
wait, it doesn't exactly answer my question. So like when they create new questions, do they get immediate feedback if the question is good, valid or not?
Oh,
or?
yeah. If the question doesn't pass the solvers, then they're just, they need to write another question, a new question. Only when they manage to submit a good question, verified questions, then they finish their task.
Thanks.
Okay. Yeah, so at this point, well, we have questions, but we actually know nothing about the reasoning process required to answer them, or if they're answerable or not. So in addition to the question, we also annotate 2 more objects. First one is the question decomposition. The decomposition is like the steps, a list of a sequence of sub-questions that are required to answer the question, while the last step returns the final answer. And the number signs are placeholders to answers of previous steps. So this to provide a description of the reasoning process.
I think we lost her again. Sorry about that.
I'm so sorry. I switched the network. I hope it will be okay now. I'm so sorry.
No.
I'm so sorry, really. I switched the network. Let's see if it's how it goes now. I guess I was froze at this point. Hello.
Yes.
Okay. Great. Yeah. So so as I said, we annotate the decomposition and also evidence paragraphs for every decomposition step to provide context for answering the question. By the way, thanks for anyone who sends me messages when I'm freezing, because it helps me to know that the internet went down. Yeah, so I just described the entire data collection process, and this is an overview. And like I said before, we just turned the collection pipeline upside down. We start from writing the question, and we finish by attaching context for answering the question. So we run this pipeline over 1,800 terms, and we update the solvers every 1,000 questions. And for evidence matching, well, we let 3 different workers to do this task, because sometimes finding the context is difficult. So by letting 3 people doing that, we increase the chance for finding the context. And another important method we are applying is that we keep recruiting workers throughout the entire data collection. This in contrast to what people usually do, that they recruit like a few good workers and let them write hundreds or thousands of questions. We always keep recruiting more workers to increase diversity. So we run this pipeline, and here are the collection results. We overall collected 2,800 questions, around that number. I didn't mention it before, but we also control the answer distribution. So we can see here that it's roughly balanced. So you can also see that the questions are both, in terms of their language, they are both simple but diverse. Simple because questions have on average 10 words. And if you count the trigrams, you will see that the most common trigram appears only in 1% of the data. And this shows that the workers do not follow like specific pattern. And they use the diverse language. Another interesting observation is that, well, creating strategy questions is hard because we actually filtered out with the solvers more than half of the questions. So it is hard for the workers to write such questions. And yeah, this is just a detail. Well, we splitted the data to train and test set based on the worker IDs to prevent annotator bias. Okay. So because we have the decomposition and the evidence, we could easily describe the complexity of the reasoning process. You can see that most of the question requires at least 3 reasoning steps and reasoning over at least 2 paragraphs. So this is nice and fulfill our requirements for multi-hop questions. We also really care, as you've noticed, about diversity. So we did 2 analyses. First one, well, as you remember, each question is initiated from a term. So we use Wikipedia properties to categorize the terms into high-level categories, like a question about humans or about a profession, etc., etc. And you can see here that this is the entire distribution of all term categories. There are in total 609 categories, and you can see the distribution is pretty flat. The top two categories of human and taxon. Taxon is for like animals and plants. They form only a quarter of the data. And we also did manual analysis. We took 100 questions, their decomposition, and labeled each decomposition step with the required reasoning skills and domains that are required to answer the step. And you can see the distribution here. So again, it's pretty diverse. You can see that you need to answer strategy questions successfully. You need to have knowledge in a diverse set of domains, biology, physics, and you also need to have many different kinds of reasoning skills, like to be able to compare numbers and dates. Yeah. Any questions before I move to results?
Yeah, I have a question. So like, it says that the data is quite complex and you have like multiple sources of reasoning that you have to do in order to solve it. And in these days, like 2,000 examples is not a lot at all. So like, do you think that it's something that that you can use that training data in order to get better in terms of this kind of reasoning, or is it more like to learn the type, like the format of the task? And if it's the second one, why not use like smaller amounts of data to learn the format and then to have the rest of the test?
So, we actually aim for the second, the second option you mentioned. I don't think really that models will be able to learn all these skills just from training on this small data. I mean, today models are trained on tons of documents, I don't know, corpora. They do have a lot of knowledge. So this is more about the format. I actually don't remember the last, you had the like if then, what was
So if it's for learning the format, why not having the amount of questions for the training much smaller than the one for the test? Because like,
yeah, so this is pretty, I don't know, empirical. I don't know, we just split the data. I mean, 2,000 questions is still not a lot. You need some amount of examples.
It's more than 500. It's not much, but it's more than 500. And it will, like as your graphs show here, it covers more, like it's more diverse, right? And it will cover more.
Yeah, you need to cover all the reasoning skills, and there are many. So if you want to catch the small portions, then you need like enough examples for that. So yeah.
Why do you think that types of reasoning can be like if you see like a few examples for one kind of reasoning, it's enough to be able to generalize on that?
So we actually we can't really check this empirically because this is like manual analysis. We don't have labels for these kind of reasoning skills across the entire data, so it's hard to tell. But I will share the results in a few slides, so maybe that will provide some insights.
All right. I think Daniel has a question.
Maybe you explained this, but I'm not sure. So Yuval's questions before was, for example, did Aristotle drink orange juice? And how do you ensure that questions can be answered by the corpus? at all?
Well, so this actually comes in the last step of the pipeline. For each question, we let the workers match evidence, and we can just see if they manage to do that or not. And we also like monitor, I mean, after the final task, I mean, once we have a full example, we also have additional tasks where we provide workers like the reasoning steps and the matched paragraphs, and we ask them if like to derive the answer step by step. And this is not done exhaustively across all the examples, but we do it on samples of examples. And we can see that, I don't remember the exact number, but I think it's 98 of the cases workers could match paragraphs. And also, I mean, I have maybe the numbers at the end, but we verified that at least for the big majority of the examples, you could match paragraphs. We let workers indicate whether they couldn't do that. So that's our method to verify that.
Right. So just to make sure. So for example, about the oranges, we just don't know. It probably doesn't appear in the corpus. So you would filter it out based on these reasonings, because oranges did exist. So you can't deny it based on the corpus.
Yeah,
right?
so actually this question would probably fall before the evidence matching, because I mean, this is not a good question, right? How would you answer this question? I mean, it's not obvious. What are the reasoning steps here?
Yeah, it's a different step, because it can be written somewhere that orange juice and grape oil are common in the Greek cuisine, but it is
but still,
kind of reasoning. Yes, of course.
Yeah, so this is a problematic question. It's not. We really try to avoid those kind of questions. Okay, I really want to share the results if that's fine, because we only have like 30 minutes. I'm happy to stay after if you want, but for those who want to leave, I'll proceed if that's okay. Yeah, so first thing that we wanted to check after collecting the data, well, it's how well humans are able to infer the required strategy and answer the questions, because it's not obvious that one could always identify the correct strategy. So we sampled yet another bunch of 100 questions and tried to answer them with access to Wikipedia. And also we had an option to reveal the decomposition. And so what you could see is that, well, humans are able to answer questions pretty well, and are also able to identify the relevant strategy. We also manually annotated, manually analyzed like the error cases, and saw that, well, the main difficulty was in finding the evidence. And that actually makes sense, because people, I don't know, they get tired if they're not seeing the relevant context at their top, I don't know, 1 or 2 results. So many, I mean, these 10% of cases, I mean, the context was in some Wikipedia page, but we couldn't get to it when trying to answer the question. Yeah, for this reason, well, these numbers are not an upper bound, because I don't know, maybe computers can do better at retrieval. This is just to show that the question answering accuracy is pretty high. Also, it looks like humans leverage their background knowledge to answer such questions, because we didn't use the decomposition a lot, and we didn't need to search for the answer of every decomposition step. Some steps we just know the answer. Okay, so this is about human performance. What about model performance? So as I mentioned before, so we don't really expect models to gain all this knowledge and reasoning skills just by training on strategy QA. So we took Roberta Large and we fine-tuned it on auxiliary data sets with overlapping reasoning skills to those we identified in our analysis. We find it on drop for numerical reasoning, 20 questions. This is a collection of common sense questions from AI2, and BullQ. This is yes/no question answering benchmark. And yeah, let's call this model Roberta Star. And we trained the following baselines. First one is Roberta Star that only gets questions as input without context at all. Two other baselines are Roberta Vanilla without the pre-training, fine-tuning, and Roberta Star that use the question as query to retrieve context using BM25 algorithm. And then the retrieved context is fed along with the question to the model. Another baseline is, well, we expect that, okay, the decomposition, well, it describes the entire reasoning process. So we expect that it should help for retrieving the correct context. So we trained a model, BART model, to generate decomposition given the question. And then we use the retrieved context along with the question. We feed the context and the question to the model. But here the retrieval is with the generated decomposition instead of the question. We trained 3 Oracle baselines. First one is a model that we just fitted with the question and the gold paragraphs from the evidence matching task. Also, gold decomposition based retrieval, where we take the gold decomposition instead of predicted decomposition to retrieve the context, and then we feed the context with the question to the model. And finally, this baseline is uses both the gold decomposition and the gold paragraphs. We train a separate question answering model on Squad and BullQ and just use it to answer all the intermediate decomposition steps in strategy QA. And then we fine tune Roberta Star just on the last decomposition steps. So, because for them, we have the supervision. Okay, so results. Well, the majority is 53.9. These are the question-based retrieval models. We can see here that Roberta without star, the vanilla Roberta, is doing pretty bad. So we will just stick with Roberta Star from now on. And we can also see that it improves over the majority. Here you can see question-based retrieval compared to no context at all and decomposition-based retrieval. And we can see here 2 things. First of all, some questions can be answered without even seeing the context. This is the 63.6. But also, well, it looks like retrieval doesn't help in terms of QA performance. So we'll get to that in the next slide, but you can see that, I mean, the best model doesn't do a lot better than the no context model. But you can see that when feeding the model with gold paragraphs, we get some nice gain of 7 accuracy points. And this shows that high quality retrieval, well, it lets the model, it helps the model to reason over the context. And using the decomposition, the goal decomposition is helpful and gives another point in accuracy. But still, this is far from the 87 points I've showed you before by humans. And these also are like Oracle baselines. So this is answering strategy questions is pretty challenging for these baselines. In terms of retrieval, so we measured recall at 10, and you can see the scores here. And well, overall, you can see that retrieval performance is pretty low. Well, most of the failure cases, we did some analysis, are because of shallow matching done by BM25. This is sort of expected because you remember we matched the evidence only after the decomposition step. So the decomposers wrote the questions for answering the high-level question without seeing the context as well. So there's little overlap between the decomposition steps and the context for answering the question. But obviously, we can see here that using the goal decomposition for retrieval is helpful compared to using just the question. But the generated decomposition is less helpful because and probably we need better decomposition models. Yeah, so just to conclude, and then we can have a QA short session. So yeah, implicit reasoning is common in real life questions and is missing from current multi-hop data sets. And collecting in such questions, well, it's very challenging, but it is possible. And well, humans are able to answer strategy questions pretty well, but it is a great challenge for models. Yeah, so I have slides here for discussion points, but maybe let's have questions first. So thank you. Feel free to ask questions.